So much and welcome everyone this morning again to our Signals Coffee and Conversation on pedestrian buttons. We're so happy that you're able to join us this morning. And like Regina mentioned, my name is Vanessa Carreo. I'm an educational program administrator with the T2 Center, and I coordinate our traffic signal efforts. I also am now supporting our Traffic Safety Academy as well, and I will be the moderator for today's session. This morning, we'll have a wonderful presentation from Joseph Herr, Chief Control and Field Operations Transportation Systems with VHB. So a little bit about the structure for today's session. Joe will give his presentation on pedestrian buttons, a little bit of history, what they are and the different types. He'll also speak a little bit on the inspection process. And then at the end, we'll open up the floor for a Q&A session. During Joe's presentation, we highly encourage you to ask questions and share comments in the chat box. I'll be monitoring the chat throughout the session, but please do not unmute during Joe's presentation. If we do have time at the end of the session, we'll open up the floor for you all to unmute if time permits. So with that, I will stop sharing and turn it over to Joe.
All right, let me bring up screen. Hopefully everyone can hear me.
Yes, you sound great.
And you got the screen on it. Thank you all. I was looking at the attendee sheet, and there's a lot of familiar faces that I have met over the years. So welcome to them, and also the folks that I haven't met yet. Hopefully you find this presentation interesting, and you can take 1 or 2 points away that will help you in your job. So PED buttons, not much to them. How do you do a whole session just on PED buttons? But there's a lot more under the hood, like most things, than you see at face value. Anyone who's done work on transportation technology, traffic signal equipment has seen a big change over the years in terms of application of traffic signals and technology used. I mean, you look at the applications we have out here now. We have adaptive signal control, flash and yellow arrow, leading pedestrian interval, transit signal priority, all these things that weren't in place, 10 years ago, 15 years ago. And we have new technology coming in. We don't have mechanical controllers anymore. Communication is more than just twisted pair. We have Ethernet communication, video detection, ATC controllers, and cloud service. So we have a lot of new technology coming in. And the same is for PED buttons. I mean, PED buttons have evolved as well. So what I was looking at with this presentation is maybe shine the light on PED buttons a little bit, on how different they are, how they've evolved over the years, and just understand some of the applications that are involved in PED buttons. I'm not going to get into specifics with one agency on what their requirements are, because there's a lot of requirements out there in place. What CONDOT does might be different than what MassDOT does, what RIDOT does, what Maine DOT does, or even the local agencies. So I'm going to keep it more or less generic in place without going into specific requirements that may be specific to an agency. So this is the outline. First, I'm going to slide into it a little bit with the history of buttons and traffic control. I'm going to have a few slides on the different types of buttons, the signs, the mountings of the buttons. Then we're going to talk about design practices and field installations. And the main focus of this presentation is going to be on inspections. How do you inspect a button? What are all the various things you need to look at when you go out there and do an inspection on a button? So let's ease into this and talk a little bit about history of traffic signals. I have a book on my bookshelf that came out from 1971 from the Institute of Traffic Engineers, not before they were transportation engineers. And it was interesting to see how traffic signal and pedestrian detection evolved. The first slide is the first modern traffic signal that was put in Syracuse, New York, built by Kraus Heinz. It was a 3-section cast aluminum head, and it was installed in 1922. Before that, there were traffic signals around, but they were semaphores, they had arms and so on. But the first modern one came out in 1922. Next is the detection. Once they had traffic signals running and they were pre-timed at first, they actuated a signal back in 1928, and this is the first detector. It was a microphone strapped to a utility pole, and if you look at the sign, it says stop and beat the horn to clear the signal. I would imagine it's not too popular with the people who lived near the intersection, but that was the detection system they used for vehicles. So they have the vehicle detector, and the gentleman who developed this was Charles Adler. So once he got the vehicle detection system in place, he came up with a PED detector. So this is the first photo of the first PED detector installed at the intersection of Charles Street and Cold Spring Lane in Baltimore, Maryland, February 4th, 1929. And this is Charles Adler's wife in the middle of the winter with her fur coat, pushing the button on a PED signal. So if you learn nothing else from this presentation, you understand that in 1929, that was the first PED button installed. A little tough, not really a level landing area, pretty high for a modern day installation, but that was the button. So we'll talk next about the type of buttons, all the different buttons that are out there, the installations, the signs, and the technology that's used in the various buttons that are out there. First one is an older type of button display, legacy type button, a small one. These were similar to the buttons that we used when I started. I started my career in the industry back in the early 70s with the City of Boston Traffic Department. And we had small buttons like these. They were very, there was no standard on the type of buttons. Most of the buttons that were installed didn't even have signs. And some of the earlier signs that came in, we didn't have PED signals. We went to a red and yellow display for an exclusive PED, usually 12 seconds for red and yellow, and then red for 3 seconds. So it was pretty simple type of system. You push the button, and you would get a pedestrian display on it. And these are some of the earlier PED buttons. And a lot of these, as depending on what agency you're with, they might still be in place, this type of button out in the field. The next type, this one shows 2 buttons on a post. One is an older button, one is a more modern button with the large 2-inch diameter on it. You got some faded signs on here. Usually when you have 2 buttons on a post, one button's for one crossing and the other button's for the crossing at 90 degrees to it. And usually have some sort of arrow display up here to let the pedestrian know which button is for which crossing. This particular photo is 2 buttons as well, but they're aligned on the same plane along the curb line. This is at a median, and one button would be for one approach and one for the other approach. This one happens to have 2 concurrent crossing. This is an exclusive PED, so this button would be for the crossing at the top, and this button at the bottom. You can see this button assembly has sort of tilted down a little bit to the pole. And also it's on an extender arm. We'll talk a bit about the extender arm, but the button's offset from the pole so that a wheelchair has access to that button. It's usually a 10-inch reach from the wheelchair, from where the wheel can stop, to the button itself. And that's this particular type of extender arm that was put on for this application. The next one is 2 buttons on a pole. This is an interesting photo because the first button that was put up top because this is a fluted pole with a decorative skirt on the bottom. These were a big challenge when these decorative skirts first came out on how you can mount that down on this skirt assembly at the bottom of the pole. So for this application, this button was in, it was too high, and what they did is they put a supplemental button on the bottom. So there is also challenges with putting in a button that's meant for a round pole when you have the fluted edges of the pole itself. And we're going to talk a little bit more about that later, but this one has two buttons. They probably call the same ped phase, but one was put in initially and then supplemented with a pull button that met the height of the button above grade. You also have buttons with the arrow underneath. This is made by a manufacturer that has the button on the pole, but the button with the arrow is underneath. So a pedestrian will go there and touch underneath the button, and it would put the call in. Also notice it says please touch. So what you would do is you would touch this assembly, and then there'd be a confirmation light coming on, and that would give the indication that a call has been put in on the bottom. This is a unique type of button. I saw this. I was on vacation in Quebec City, and I saw this. I guess that's what you do when you go on vacation, take pictures of ped buttons. But I happened to do this up there because it was unique. There was a few unique things with this. Number one, it's mounted above this skirt assembly on the pole, but it was not a tall assembly, so it was fairly reachable, probably around 42 inches up. The button is underneath, like the previous slide. You had the confirmation lights up on the top, but also you had the challenge of the fluted pole. So for this one, they put a bead of clear silicone on the top to stop any water coming down to get inside the assembly of the button underneath. You also notice there's no sign on the top here that gives an indication to the pedestrian which crossing it is, doesn't tell much about the walk, flash and don't walk interval, and so on. And again, this one's from Canada. The next one is an extender, similar type of button I showed before about hitting it. It extends it off the base because you didn't get the 10-inch reach. The foundation's pretty big, so you really couldn't bring the sidewalk right up to where the anchor bolts were. So what they did is they put this extender support on and mounted the button right on this extender part. I had the sign up top. And the other interesting part of it that we'll talk about is it looks like they put a hole in here already on the pole, and they realized they weren't at the height, so they moved it down. But when we talk about an inspection, that type of hole should be sealed properly on the assembly. Also, depending on where it gets mounted, you come up with some pretty creative mounting assemblies. This is actually on a bridge. This is the lighting on the bridge, and to get it available with that 10-inch reach, they come off here with the pipe. They go vertical with the pipe assembly, and they have access to for the pedestrians to access the button. I'm sure that this had to be a custom made with the banding around the lamp, and then routing the cable into the back of the pole so we get access to the button. Sometimes you really have to be creative to get access to the button. This is in a downtown urban area in New England, and there was a fence there. I'm not sure what came first, the fence or the pole. I believe it was the fence, because the sidewalk is very narrow, and if you put the pole on the sidewalk, you wouldn't meet ADA minimum width for the wheelchair. So they had to put it in the grass area behind the fence. And what they did is they took out 4 of the vertical portions of the fence to allow the pedestrian to get access to the button. This one just happens to be a miss by the agency. I don't know the backstory on it, but I can imagine when it initially got designed, there probably was not a vegetation on the bottom. This planting area with the curb and the dirt was not there. So I'll bet another project came in. They added the curb, they added the landscaping, not taking into account that you needed access to this ped button. It is still that way today. You don't have access to it. And a lot of times what happens is when there's something done after something's been accepted and it's been out there for a while, that you run into issues, in this case with the ped button. I remember when I was with Boston, every once in a while a sign would be installed, or a utility pole was installed on a street corner and would block the vehicle head or the pedestrian head, or in this case, the pedestrian button. Sometimes coordination between what goes on a street corner is not the best, and you end up with situations like this. And this one happens to be for a PED button. The signs are a little different, going around, some interesting signs out there. This sign was actually put in Providence, Rhode Island during COVID. They didn't want folks to go and push the button. So what they did is they put the phases on PED recall in the controller, and they put this over the sign. They didn't do any wiring. They didn't disconnect the wiring. The calls went in because the controller was on PED recall, and it just prevented or minimized the opportunity to spread the disease with the knowledge of how it got spread at that time through touch. So these signs are being taken off. They adhered pretty well out there. They were good adhesive, and they stood on pretty well. But the sign was to let the pedestrians know they didn't have to push the button, that it was automatically going to come in. Other different signs. This is in an urban area at a rail spur, and this button was actually used by the conductor from the train that pushed the button and get the preempt phase. Again, this was a spur. It's not used anymore, but they put this sign over the PED button just to say what the button was for. It's pretty far away from the intersection, really only accessible in the railroad right away, but that's another type of sign. Some other signs are more graphical in nature. This is a graphical sign. Shows the direction. Again, it doesn't say much about the PED signals, the walk or the flash and don't walk or the don't walk, but this is a sign that's installed on the button. The MUTCD has a whole listing, R-series signs that an agency can use to put on a button for various applications. This one, again, from COVID, manufacturers came out with different technologies, and they have the non-touch buttons. So all you had to do was put your hand in proximity of the button, and it would put the PED call in. So this one gave you the option of just waving at the button, or you could actually depress where the arrow is to put the call in. These are I've seen these in a few places in New England. I've seen it up in Maine. I've seen them in Massachusetts. They're not very widespread, but every once in a while you'll occasionally go out there and see it. It's pretty interesting just to go by and just wave your hand and see that confirmation light go on, seeing that call did go in based on just your proximity of your hand to the button itself. They also have buttons and signs for RRFBs, obviously different than at a traffic signal. It'll just say that the warning lights are turned on, and the button itself would be the same type of button with a 2-inch diameter confirmation light, but the sign would actually indicate that it was just to turn the lights on, the RFB lights, so a pedestrian can walk across the street. This one might be a little different. I have not seen this in New England, but it is in the MUTCD. I know California uses this in various spots in California, and it's meant to accommodate elderly pedestrians or pedestrians who can't walk at the rate of younger pedestrians or pedestrians who are more able to do so. And if you hold the button down for 2 seconds, what it will do, it will make an adjustment to the pedestrian clearance time. Typically, the pedestrian clearance time is calculated by the distance of the crossing based on 3.5 feet per second. So this one may take it down to 3 feet per second. So the PED clearance time will be extended with that button being held on for that extra amount of time. That changing the PED clearance time would be done in the controller. The controller would recognize that input and would be programmed to recognize a PED call for more than 2 seconds. Just speaking on the operational end, if you ever put this in, you'd have to be cognizant of how it may impact coordination, because typically when you run coordination, you have to take into account fixed intervals with your split time. So if your flash and no walk goes from 20 seconds to 28 seconds, you just want to make sure you don't, blow out of coordination based on the fact that you have a longer fixed interval, longer flash and no walk fixed interval time. But again, I've not seen it in New England. Not to say that it hasn't been used. I haven't been to every intersection, but there are some agencies that do use that, especially near maybe a senior citizen's home, or maybe a hospital or some other application that's out there. And again, that's a sign that would be put on the button, probably supplementing the button sign that's typically there. This is the normal
Joe,
button. Yeah.
I was just going to say there was a comment made about that. So Jinhong Wang said, I think the reason for the 2 extra seconds is Caltrans assumes 4 feet per second instead of 3.5 for ped crossing timing. They allow 2 seconds extra to accommodate elderly crossing.
Great. Yeah, I was actually involved on the 2-second number. We did I work with the University of Wisconsin doing a study on how long it would hold, but and it came up with 2. But yeah, thank you for that information. Like I said, every agency is a little different. In preparation for this talk, I was looking at various white papers that are out there, and each one did a little different. But Caltrans was pretty on the forefront of doing conditional timing based on bike signals and also pedestrian and so on. So I appreciate that feedback.
Thank you.
This is what typically looks like. Again, there are various vendors that are out there. Accessible pedestrian signal buttons typically look like this. This is one of the signs that is shown in the MUTCD. It's very informative to let the pedestrian know what the different displays are. The arrow indicating what direction is on, and it aligns with the button, the arrow that's on the button to show the direction of the crossing with the confirmation light. You can also have dual direction buttons that show both directions on it and also show both directions. This is on a median where the crossing, it's an exclusive PED, so it shows that both crossings would be active at the same time, and to cross either way, you push the button, so there'd only be a single button in the middle, in this case, in the middle of this median. The top 2 definitions on this slide from the MUTCD, the 2023 edition, on what a PED button is and what an accessible pedestrian signal detector is as well. In the bottom is the ADA requirements, and it's good to have the requirements. I remember when the requirements weren't there, and again, the diameter of the button itself was very small, and it was difficult for some folks to actually press it, especially if it was recessed and you're out there in the winter with gloves on. You really didn't get a chance to activate that button. The other one's the maximum force. There was a few button brands out there, and the buttons were actually from heavy equipment, and it was very difficult to depress the button with sufficient force to put a call in. I mean, they were like 30 amp buttons, heavy duty buttons. So ADA looked at that and said, hey, we're going to need a maximum amount of pressure needed to activate the button itself. Be accessible to wheelchairs, to be located within a certain distance from the curb and the crosswalk, face parallel to the crosswalk being used, must be usable with one hand, need audible and vibro-tactile features to guide pedestrians with visual disabilities, need locator tones to help visually impaired pedestrians find the button, need to have a raised arrow, and have an audible feature that automatically adjusts based on the ambient noise level. The next is design practices. I'm not going to go through all of them. I have a couple of slides on design practices and a couple of slides on field installations that I'll go over. And the first one is the level landing area, which is always a challenge when you go out there and do inspections to find out where the level landing area is relative to where the button is. A lot of these as you can see, they've already been constructed. And it would really help out if an RFI came out. Sometimes poles or support structures have to be changed because there's underground utility conflicts or other situations that may require that pole to move, and all of a sudden you're not aligned with that 4x4 level area. So this top left photo, shows the buttons, but you can see that grass area. It's missing the level landing area. So what's going to have to happen is that sidewalk's going to have to be extended so that pole that button can be adjacent to it. And the other thing it shows, especially with the second one, is the size of the foundation. Sometimes the foundations themselves with the pole and the anchor bolts there, you're not going to get the 10 inches with the button to that level landing area. So other creative supports have to go in there in terms of an extender or some other means to meet that 10-inch reach requirement. And then this bottom photo, you have the button adjacent to one of the wings of the wheelchair ramp. This panel is sloped. It should be less than a 2-degree slope. So having that needing a level landing area next to this would have to be that would be a problem during the inspection. Next is the extension reach. Usually during the inspection, we'll go out there, maybe do a plumb bob to find out where that lands next to the curb, and then do a lateral measurement to see if we meet that 10 inches. These extending brackets are different. Each manufacturer is a little different. There are some that articulate on more than one plane. They have ability to go left, right, up, and down. This one is really doesn't have much of an opportunity to create a little bit of an angle to make that parallel with the crosswalk. So it's a good thing when shop drawings are submitted, or maybe when the spec is put in, that the extender has the ability to articulate to accommodate maybe some of the geometry and some of the crosswalks that are put in there. Field installations. This one shows non-compliant where the button really does not direct the pedestrian to the crosswalk. It sort of goes at a 45-degree angle out, where the photo on the right where the crosswalk aligns directly with the crossing itself. That would be compliant. And secondly is the challenge in field installations, again, when you have a fluted pole. When you have a fluted pole, the angle of your button is going to be dictated by the orientation of these grooves on the fluted pole. So sometimes there's creative ways of putting standoffs in there, or maybe putting banding straps in there and so on. So if you're going to call for, as a designer, that you can have fluted poles, just understand that there may need to be a construction note on the plan, or some understanding that may be a challenge for the contractor to meet that without special accommodation for the button to the pole. All right, the main focus is inspections. Checking the button. How tough is it to check a button? Well, here's a photo of my 2-year-old grandson checking a button at a toucher truck up at MassDOT District 6. They had a toucher truck, and the district electrician had set up signal equipment and connected a PED button. Jackson went in there, pushed the button. It was actually wired up to this 3-dial Eagle electromechanical controller. It had the dial go. It went yellow, red. The walk came in, and my grandson did a nice job of checking the button. But it's a little bit more than that when they say check a button. So what I'd like to do is go over the different steps of how to check a button at an inspection. First, what do you do with the traffic signal inspection? What is an inspection for a traffic signal? First, it's compliant with the plans and the specifications to make sure that what's installed beyond the buttons, the heads, the signs, the pavement marking, and so on, are compliant with the design plans and specifications. It's compliant with agency requirements. Agencies typically have a blue book, ConDOT, MassDOT, MainDOT. They all have supplemental requirements that go along with the plans and specification. There's also requirements by national requirements, ADA, AASHTO, MUTCD, National Electric Code, National Electric Safety Code, NEMA, ATC, and so on, the whole alphabet soup of national requirements that have to be looked at. And operational requirements, there may be specific things on the plans, on the construction plans that need to be looked at during inspection as well. Hey, I don't want a yellow trap, or this is what I want with at a real grade crossing, or maybe detector switching, or overlaps, or leading pedestrian intervals. So there might be specific applications that are non-standard. You have to take a look at that as well. For me, I've been doing inspections for a long time. Before I even pop a cabinet out, I like to, you're not out there to do a design review. That's already been done. But it's a good idea to go out there and take a look at the intersection itself before you even start doing an inspection. Just take a look at the ped heads, take a look at the vehicle, take a look at the lanes, just have an overview. Sometimes when you do an inspection, you could be too close to the forest to see the trees. And it's nice to have an overview of how it's supposed to operate based on your experience and understanding how things work. And of course, most importantly is public safety. You have to make sure that that infrastructure, that signal that's put in, works properly and works safely. And that's the most important part of an inspection. So let's go one by one. Number one, make sure it's a proper model and color. Usually shop drawings come in and it's the model is there, the color of the buttons are there, the support is there. This particular one, it was a swing and a miss. They had a black support with a yellow arrow. We understood what was submitted for a model, and this was put on the punch list to get rectified. Secondly, understand where the ped heads are going. I mean, if you have a T intersection, a four-way intersection, it's pretty straightforward in terms of the vehicle heads and the ped heads if you've been doing this long enough. But sometimes they can get pretty complex. What I usually do is bring out a copy of the plans, and I'll say, okay, this is phase 2 ped, this is phase 6 ped, this is phase 4 ped, and so on. It just makes it a lot easier to understand that this ped's associated with P3 and P4, and it's a phase 6 ped. Just mark it out in red and just understand if this makes sense and you understand how it's supposed to work before you start going out there and pushing the button and start looking at the physical and operational items of the intersection itself. Next, make sure the call goes into the proper phase in the controller. A little advice on this. Depending on the controller manufacturer, there's a screen on there that is active status. This is status that locks in. This is a phase 3 ped that showed on this Eagle controller. And that locks because it's a locking call. All ped calls lock. But there's an intersection screen on the controller that if you hit the button, this C will go on and off depending on the status of the button. So that's the one that you want to look at, is as the person who's pushing the button and the person who's at the cabinet can understand if that's actually putting a valid call into the proper phase of the controller. Make sure that the walk signal comes up for the button. Make sure that the walk indication comes up, and look at both. Don't just look at the one adjacent to your button, but they always work in pairs. So take a look at the other ped signal at the same time. Make sure that display corresponds to what your call is. Next, check the countdown operation. I have been on inspections where you start counting down 13, 12, 11, 10, and all of a sudden I'll get a letter. I'll get an A, a B, a C, a D, a letter instead of a number in there. It happens. It could be a malfunction. It could be the way it was programmed. But take the time to look at the whole countdown to make sure all the numbers come up, all the displays come up, and it works properly, that the countdown does work properly. Again, make sure this one corresponds to its pair on the other side of the intersection. Next, to make sure it meets the ADA reach requirements. I talked about that before. Make sure it's 10 inches out. And again, I'm not going to claim to be an expert on ADA or the sloping and so on. We usually have someone who is well versed in that. I usually go out with them, and they're out there with the smart level, and they're out there understanding all the ADA and PROAG regulations. But you look at it from an operational point of view, that 10-inch reach from where the wheelchair would be to where the button is important to look at during the inspection. Next is the reach. Again, there are different requirements that are out there, but it's typically that 10-inch reach that is there. just be versed on it. And again, I do inspections across a lot of different agencies, so understanding the unique requirements that may be for that one, for that specific agency is important before you start going out there to do an inspection. Next is the 4x4 landing area. That's pretty traditional to have that 4x4 landing area adjacent to the ped button. So when that person in the wheelchair is pushing the button, they don't have to worry about rolling away from the button. They're on a stable surface, a flat surface. And typically what happens, it has to be less than 2 degrees. And that's where the smart level comes in. You can put it on there. Usually a photo's taken, so it's documented what you looked at, what your findings were, and that would go along with the documentation as part of the inspection. Next, to make sure that the button and the sign is aligned with the crosswalk, that it is parallel with the crosswalk, to make sure that's there. Early on, the contractors, I found, really didn't recognize that fact, but most signal contractor who install intersections have come to know that. They're aware of it, and there's less punch list items where this doesn't correspond. And they also drill out properly where it goes on the pole, so you don't have to fill the gaps in post installation. Next, to make sure the arrow is pointed in the proper direction. Left button, you can see the arrow on the sign is pointed to the right, and the button, the actual button itself is pointed to the left. That's not correct. This one's at a median island. It's supposed to have 2 arrows here. It has 1 arrow to the left, but it's supposed to have 1 to the right. And the button arrow just goes straight down. I'm not sure what they're thinking they're going to go to with that, but it's straight down. Obviously, they probably didn't have an arrow that went in both directions. But just make sure that the buttons are for the proper direction, and both the sign and the button itself correspond in the same direction. Next, make sure the confirmation light is on. If your button is so equipped, this is like an elevator button on a building that lets the pedestrian know that, hey, that button's, you push the button, it's been acknowledged, and this confirmation light typically lights up at all the buttons that are assigned to that pedestrian phase. If it's an exclusive PED, all the confirmation lights will go on, and you check that at each individual intersection. Next, the locator tone, to make sure it's audible from a 10-foot distance. That's 10 feet away. This is pretty subjective. I know early on you have decibel meters out there. I'm not sure how well they work in traffic conditions. I'm older than most people that do the inspection, so my hearing maybe is not as good as someone who's younger than me. But you try to get that, at least acknowledge that they're looking at 10 feet to be able to hear that locator tone. So someone who's sight impaired, someone with a disability, will know where the PED button is. So you try to go out about 10 feet and see where that locator tone is, and that can be adjusted. These buttons, I should have said at the beginning, they're programmable in terms of what the message is, how sensitive it is, ambient noise, and so on. They're all programmed. They're programmed through infrared, through plugging into a laptop. There's various ways of accessing the programming within each of the buttons. Next is make sure that if the buttons are close together, they have the appropriate sound. Typically, if they're less than 10 feet, they call for text messages to say, hey, it's the walk signal is on across Main Street, or the walk signal is on across Side Street. So there's no confusion for a pedestrian to know which one is active at that time if they're less than 10 feet. If they're more than 10 feet away, then that's not a requirement, typically not a requirement. Make sure the text message meets specifications. Sometimes it'll be in the spec to say, hey, all the buttons have this message, P1, P2 has this one, and so on. I happened to be on an inspection yesterday in a large city, and it said walk sign is on across Rubble Road. There was no Rubble Road. It was wrong. So you want to make sure that the message is correct. There's very specific text that you want to put in there. You never want to say it's safe. You just want to give the condition of the sign across to the pedestrian, so they know when that walk sign is on. Next, you want to make sure that ambient noise levels, I mean, there's a button next to a fire station. What I usually do is go out there and I start clapping next to the button, so that locator tone will go up in volume based on that background noise, so again that a person with disability, someone who has hearing or visual impediments, will know where the PED button's in under all conditions, say heavy traffic and so on. Also, make sure there's no extra holes drilled into the support pole. This one has an extra hole here. That has to be plugged properly. You really don't want to put duct seal in there. Duct seal is not going to do it. I've seen that 100 times. You want to put something in that's meant to plug it in. Maybe a toggle bolt in there with a washer. They do have, industry does have devices to be able to put that in there, but you don't want that left open where water can get inside the pole. Next, you don't want exposed wiring in here. This one has wiring that comes in with duct tape. Nice try, but this will be a maintenance issue down the road. This is not acceptable during an inspection, and it has to be taken care of so you don't have any exposed wire between the support bracket and the button assembly itself. You also want to make sure there's no gaps between the button and the pole. Again, that one up in Quebec City, they put silicone on the top. Again, you don't want to use duct seal. Put in silicone, make sure it's permanent so you don't get water penetrating the inside of the button. Next, you want to make sure that the brackets, the standoff brackets, are meant for that application. This is not meant for that application. They got 4 shims here. And also, if you notice on the bottom, they have a wire that comes in on the bottom that's exposed. So you have to make sure that you have the right equipment for the right application. You also want to make sure the mounting screws are stainless steel. This one's already starting to rust. We also have a missing screw here. This is stainless. You want to make sure whatever hardware is used is made for outside applications. The last 2 on this list is, number 1, they can be hacked, those crosswalks. This is April of this year out in California. Again, California seems to be leading the way in a lot of things. They hacked it and they imitated voices of certain national figures. It comes with the password. It's a good idea on anything you put in a traffic cabinet to change the default password on whether it's a router, whether it's an Ethernet switch, or it's a PED button, to try to keep bad actors out so you don't have buttons that are hacked. And last, and probably the most important, is make sure there are no conflicts present. What do I mean by conflicts? Well, you got vehicle conflicts, green against green, green against yellow, green against walks, but you also have conflicts between the buttons and the displays. And what I mean by that is when the walk signal is on, the button will vibrate. So it'll give an indication that it's a go indication to go across the street. When I check this particular intersection, I press the button to walk across, this button here to walk across here, and it wasn't vibrating. This button was vibrating, letting a sight impaired person know that this crossing was all right. And this was green at 45 miles an hour. So it was a conflict. It was a wiring issue when it was initially installed. So what happened, this button, which goes across here, was connected to the wrong PED head. And that was done out in the street. You had 2 PED buttons, 2 PED signals, and it just happened to have cross wiring on it. And fortunately, it was caught during the inspection. We stopped the inspection, called the resident in, and we had the contractor come out and make that change, because the last thing you want to do is leave a conflict at an intersection and have the chance of a sight impaired person getting that go indication from that vibrating arrow, that button, and having them go across the street on a 90-degree conflict with 45-mile-an-hour traffic. So it's real important to check that out. Hold that button. Just don't do like my grandson did, push the button and walk away. Make sure that you hold the button and look at it. And this is my last slide. When I was doing this presentation, the weekend before, I went out for Chinese food with my wife, and that was my Chinese cookie, the little label that came with it. And even though a button's a button, it may seem simple. There's no job that's so simple that it cannot be done wrong. So I thought that was an appropriate message that I can pass along. So even though it's just a simple in function of technology, it still has to be done properly. So that was 45 minutes, leaving 15 minutes or so for questions and answers. Hopefully, what I presented for material was useful, that you found it worth your time investment. And if you have any questions, again, I don't know everything. If I don't know the answer, I'll reach out to a lot of smarter people in my Rolodex and get it back to you. But I'll try to answer whatever questions that I can help you out with.
Thanks so much, Joe. And just a reminder to everyone, this session is being recorded and will be posted to our T2 YouTube channel. So we did have a couple of questions in the chat that I'll read off to you, Joe. And you may have addressed parts of these questions, but if you have anything else to add, please feel free to do so. And in the meantime, if you have anything that came up, participants that you want to put in the chat, comments, questions, feel free to do so now. So the first question, any guidance on placement or visibility of the PED signal heads? Is there an advantage for pedestrians to not only be able to see the heads for the street they are crossing, but also the heads for the other street? This would pertain to a concurrent or LPI operation.
Great question. Usually when the ped heads go in, obviously it's line of sight so that they can see it. But the other thing is construction. If you have a ped signal on a corner, what you usually want to do is place it so it is not hit by a turning truck. I mean, you want to put it on the back side of the pole, away from where the truck radius would be. So it's a lot of times it's maintenance considerations on where you put it on the corner. A lot of times supplemental poles will go on. It's nice to say, hey, I have a mast arm shaft here. Maybe I'll put it on the mast arm shaft, and maybe it's put in the middle of the winter or at the end of the winter, and all of a sudden you realize there was a tree that's there. So you have to worry about vegetation blocking the ped. So adding a pole, adding a 10-foot pole around, because even though it might be easier, you don't want to have clutter of poles on a corner, but you also have to be cognizant of the sight distance. And again, if you can put the ped head and the ped button on the same pole, that cuts down on the amount of infrastructure that you put on a corner. You always try to make it as efficient as possible, but at the same time, you want to be able to address things like ADA, the proximity of the button to the crossing, and also having the PED signal align with the crosswalk as close as possible.
Great, thank you. So next question, where is the technology going for pedestrian buttons? Will we need them in the future? Cell phone to button, to cars, to Fitbits?
That's a great question. It's funny. It reminds me. I saw an article in IEEE Spectrum, the magazine, about 6 years ago. It said, "Kill the traffic signal." Do we even need a traffic signal if at some point we have if we have autonomous vehicles that can talk to each other, and you know the trajectory that vehicle is not going to occupy the same piece of asphalt at the same time? I mean, that'll be long after I retire, but eventually with autonomous vehicle in speaking, that's where connectivity is going right now with connected vehicle technology. We've been involved in a number of projects with connected vehicle, and it can put out basic safety messages saying that there's a pedestrian at the crossing to the motor vehicle. It goes up on an app right now, but eventually it'll be part of the display in a vehicle to say there's a pedestrian there, and also bicyclists. I mean, the more information we have, the smarter our traffic signals can be. I mean, back in the day, your detection was point detection. Now, using AI, deep learning, you can do classification. You understand where bicycles are, pedestrians are, what type of vehicle. Is it a WB50? Is it a pickup? Is it a bus? So I think where things are going, I think AI is gonna it'll creep into everything we touch, and it'll touch into traffic signals as well. And all of a sudden, our ability to manipulate timing, to be able to adjust, say, an adaptive system based on volume, occupancy, and speed will help mobility. It'll also help safety because all of a sudden you don't know what type of vehicles are coming. Maybe you understand vehicles are coming at a certain speed and they can't, they're not going to stop. Maybe you delay the side street coming in. So as we get more and more technology, more and more data through signal performance measures, for example, I think that's where the future's going. There'll always be a need to activate it, to have a pedestrian there. And the challenge always is the pedestrian just standing there, or is the pedestrian wanting to cross the street? So even though we might have video and other, it still needs to be conditional based on what they're doing.
Thank you. Do you recommend any PED isolation to protect the button against power surges?
Boy, that's a great in the weeds question. Uh, yeah, 170 controllers have had PED isolation for a long time. 170, 2070 assemblies were used by New York State DOT. There are some assemblies. City of Hartford has 170, 2070s. Bridgeport as well. NEMA didn't have PED isolation. They took the 24 volts. When you push the button, you grounded that 24 volt input into the controller. The new generation of cabinets beyond NEMA, right now, NEMA TS1, TS2, the new generation is ATC, Advanced Transportation Controller Cabinet, that MassDOT and MainDOT have adopted as the new standards. They all require PED isolators in their rack assembly to isolate the button. But again, the voltage going out there, you don't have 120 going out to the PED button, so you really don't have shock hazard, a high voltage hazard. The one good thing about a PED isolator, it isolates the back panel. So if something happens, you do happen to get 120 on that conductor that goes to the button, you're not going to blow out the whole interior of the cabinet. You'll just take out the PED isolator that's in a rack. So from an electrical point of view, from a safety point of view, that's the way it's going with the again with the ATC cabinet assembly.
Great. A couple more questions. Any advantage of applying PED recall for selected phases in Connecticut municipalities, not New York City or Boston? Are PED buttons still required with PED recall mode?
I don't know. That last part, that's an agency call, whether they're going to have a button or not. If you're going to have it on recall all the time, you don't need a button. PED recall you can make based on time of day, per cohort plan. So it's very conditional. You can do it when you're running the AM peak or the PM peak and so on. I mean, it's really application specific on PED recall. In an area that has a lot of pedestrians, next to a college or university, or some generator that generates a lot of PEDs during the day near a school, maybe. It depends on the application that's there. One of the challenges with the PED recall is if you're running coordination, is you're going to have to take that PED timing into account in your split timing, not to go down the rabbit hole. But if you have a 10-second walk, 10-second flash, and no walk, you're going to need at least a 20-second split. I mean, you could probably longer if you add the yellow time in, so that you're going to always take that in. If you don't want to give a 20-second split all the time, you can give 15 seconds and understand when the PED call comes in, you're going to drop out of coordination. But if you have it in recall all the time, you're going to have to adjust your split time to accommodate your fixed interval, which is your walk and your flash and don't walk time. So it's just something to keep in mind. It may impact your emergency vehicle preempt if you don't truncate your pedestrian clearance time. If you have your PED clearance time coming up, you may end up having to detect that emergency vehicle a lot further out, or it may impact grade crossings as well if you don't terminate it on when you detect a train and when you get a real preempt call coming in.
Thank you. And last question we have in the chat for now. Have there been any issues with clients with vehicles sideswiping the extenders that you know of?
I saw them climb the pole during,
Yeah.
kids near Saturday night using them as a step going up. Um, yeah, vandalism. I haven't seen it with vehicles hitting them. And again, you have 10 inch. You don't have to go right up to the curb line. You can be back a little bit on it. Um, I have not seen vehicles hit it, but but it is definitely a consideration during the design. I mean, when you do a signal design, you always look for ways to minimize something getting hit, especially with a cabinet. You don't want to put a cabinet in a place that vehicles taking left or on a T intersection, put it right in the middle of the T on the opposing sidewalk. You try to help out the agency, help out the maintenance people by making it such that it's not a target and it's not prone to getting hit, which gets back to the earlier question about the ped signal. If you have a lot of heavy trucks in a tight radius, you're going to have those trucks go over the curb sometimes. That's just the way it is. You want to make sure that whatever infrastructure you put out there, whether it's a ped head or ped buttons on an extender, go back a bit. So I wouldn't be surprised if it happened. But me personally, I have not seen that specific instance where a ped button on an extender has been hit by a vehicle. So
Yeah, and just a follow-up question to that was just posted in the chat, and this will be our final question. But any issues with extenders blocking the sidewalk path?
be careful of that. You
Yeah.
you really have to be careful of that because again a sight impaired person, you can't have something as an obstruction or something low that would impede that they'd run into. I mean, yeah, that has to be looked at, and it can't be in that right of way within it. But yeah, that definitely has to be taken into account when a ped extension is put in there, that it's not blocking the minimum right of way for a walking path.
Yeah, thank you. So I'm just going to share our closing slide here. There we go. Joe, you did an amazing job. Thank you so much again. We appreciate you taking the time to develop your presentation and share your expertise with us. And to everyone who participated this morning, we hope this session was a valuable use of your time. So we have an evaluation QR code that's posted on the screen here. Regina also posted it in the chat as well, a link to the evaluation. We want to know what else you'd like to hear about, what else you'd like to learn in our coffee and conversation format. So we really appreciate it if you take the time to fill out our evaluation for this morning's session. And thank you so much, everyone. Have a great rest of your day.